Good morning and welcome to the homestead. So this is part 2 of how to survive the end of the world. No, not really. I'm going to give you a little portion of how to survive the end of the world. So in today's video, I really want to dive into how to kind of protect your equipment, your electrical equipment that is, against the nuclear EMP. So I'm going to focus solely on nuclear EMPs in this video. We've talked about utility surges and we've talked about solar flares. All the common products going to work for that. Placement is not quite as critical. But if you have any chance of surviving a nuclear EMP with your inverters, charge controllers, refrigerator, portable generator, whatever that case is, there's a lot of things you can do to help yourself. I'm not going to go as far as to say that any of these devices will definitely protect you. I'm not going to tell you that if you buy a EMP add-on to your solar arc inverter, it's going to survive guaranteed. There's way too many variables in a nuclear EMP to make you any promises. What I am going to tell you is there are a lot of things you can do to put yourself into a position that will better your chances. That's the best way I can say that. If there's a nuclear blast in the sky with the intention of wiping us out from a technology standpoint, then these are things that you can do to help ensure you might have some equipment running after the fact. Of course, the first one is if you're into communications in any way, if you can find an old tube radio, HF amateur radio, for example, they're fairly immune to an EMP compared to like stuff like this with all the microprocessors and stuff in it. The other thing you can do in a vehicle standpoint, we can do a whole video on this one later, but you can have something like our old 94 Dodge. It's a 12-valve Cummins diesel mechanical injection. It's a standard transmission. So it requires absolutely zero electricity to run. From a factory standpoint, it does use power because it has a solenoid that pulls the fuel open, holds it open while it's running down the road, and the computer runs things like the dashboard instruments and stuff like that. But from a physical standpoint, you can actually get under the hood and take a zip tie, pull the fuel rail open, zip tie it open, push it down the hill and pop the clutch, and it's going to start and run just like it normally would. So that type of thing, you can do that on your automobiles. A lot of the more modern automobiles have a fairly hardened computer already. There's a lot of speculation on what may or may not survive. So we're going to really dive into like your power system, your house, your cabin, wherever it is you live in, and what you can do. Obviously, you've all had experiences with your cell phones where maybe you go to your friend's 1972 mobile home like ours here in Florida. You go inside and the phone doesn't work. It's all metal siding, all metal roof. That is what we call a Faraday cage. Not a very good one in the case of our 1972 mobile home because it has windows and stuff, but that's what you're experiencing. That's why the phone doesn't work well. So you can actually put spare products. Let's say you want to keep a HF amateur radio so you can make communication around the world after the blast. You can put one of those in a Faraday cage. And I'm not going to go into details on what a Faraday cage is. There's a million ideas out there on what they are. It can be as simple as like a metal trash can lined of cardboard. The key here is the device itself wants to be completely insulated from the cage, the metal cage, if you will. And the theory is the metal cage will absorb that nuclear blast. It doesn't go through the metal, it goes around it, and the device inside is insulated and stays safe. So first thing you can do is put spare equipment in a Faraday cage. With that, I would say that you probably want to think about when you pull that equipment out. An example of that is, let's say there's a nuclear blast right now, everything goes dead from an EMP. I know it's an EMP, you know it's an EMP. Don't run over to your Faraday cage, rip it open, grab your radio and plug it in to see what's going on. Because if anybody is smart, when they do that to us, they would do a second blast hours or days later to take out any of that secondary equipment. Or there may be multiple blasts that aren't perfectly timed. Like you've watched a show named Jericho, like I mentioned earlier. Those were all timed, but maybe they're not timed. Maybe they're off by an hour each or something. So that's my word of advice on a Faraday cage, but that's probably the best thing you can do for guarantee. The second thing is antennas. And what I mean by antennas is any piece of wire is an antenna. So this 16, 18-inch piece of wire right here, if I hook that up to my HF radio right now, I could receive a signal on that. I would hear other people talking. It's not a very good antenna, but I'd hear something. I make that 20 feet long, I get way more signal. So that is something to think about, because what an EMP is basically an electrical radio wave running through the air, just like what you pick up on your TV or your FM radio or AM radio. I mean, it's not the same radio wave, but it's the same idea. There's electricity flowing through the air that will hit that wire will absorb it as an antenna, and all your products will become energized. So the more antenna you have, the worse off you're going to be. So if you're living off-grid in the mountains, in Tennessee, don't have your generator shed 200 feet away. Don't have your PV array 600 feet away. Keep those things condensed in. Or if you're worried about it, have a cord between your generator and your solar system that you can unplug when you're not using the generator. Unplug both ends, coil it up, and throw it out of the way. Now that generator over there is all by itself, and it has less antennas. So the antenna is the number one thing to think about. If you're grid connected like we are here in Florida, we have a massive antenna. We have antennas that stretch all over Florida, up through everywhere here, all interconnected, that will absorb that EMP and dutifully pass it along to every one of us that are connected to that power pole out there. So in that case, your options are a little less limited. What you can do, you of course can have some spare equipment, a Faraday cage. You can try to put a lot of this stuff on your equipment, and that can help. But if you're too close to the core blast, as we talked about last time, that's not going to help. But let's just focus on what we can do. And today, let's focus on surge arrestors. And what you're going to want to do is make sure that you're protecting everything that you can protect, that you can afford to protect, and as often as you can. So what I mean by that, it's a little confusing and it can be a little daunting to understand where to put stuff like this. So if you're grid connected like we are, the very first place you put one of these is right at the utility panel, as close to that main breaker as humanly possible. And what I mean by that is, if you look at your breaker panel, you get the rows of breakers down through there. The main breaker's on the top. Wire this up to the very top breaker. And that way, if there is something coming in from the utility, this is going to be clamping everything together and maybe blow the main breaker before it gets down through the bus bars. So you want one of these there. If you've got an outbuilding like this building here, it's 50 feet from our utility pole. You want another one of these right in this building where the power comes in. Now, when the power comes in here, this is what's called a sub panel. Your neutral is actually separate from your ground in here. And you might say, well, gee, Ryan, it's bonded back at the main panel 50 feet away. And that is correct. But if you took that 50 feet of wire and you took an EMP or a lightning strike and you have that hit nearby, you're going to measure some serious potential between those two in here. So that's one thing that I'm going to point out, that like the Midnite SPD, for example, only has a red, black, and a green. So if you really are focusing on EMPs, you're going to want to put two of these in this load center in here being a subpanel. And you're going to want to use one of these with the white heat shrink on the neutral, because the neutral is now basically a current carrying conductor in here in my mind, because it's far enough away that voltage can rise. It's hard for me to explain, but if anybody watching has played with amateur radio, you'll know that an amateur radio antenna can be one solid piece of copper pipe, but because of how it resonates, they're electrically isolated from each other during that frequency. And that's the same thing with an EMP, is that even though it's bonded back there, those two wires being separate out here, a lot of voltage can build in that wire and come out this way. So the load center out here, put one of these immediately as soon as you can. Put a second one for the neutral, unless you've got one like a Square D or something that does the neutral. And then after that, what I tell people is any wire that's 50 feet long or longer that has something on the end of the wire that's worth protecting. And now if you're truly worried about like the end of the world scenario, an SHTF and a nuclear blast, you may want to reduce that wire length down to 10 feet. It just depends on how much money you want to spend to try to ensure the system may survive this blast. And the logic I use there is, like, let's say you've got a $200 Harbor Freight generator 100 feet away out in an outbuilding. It probably doesn't warrant a couple $100 for surge suppression or $400 for surge suppression because it's a $200 Harbor Freight generator. But now let's say you've got a $5,000 Onan generator out there. Now you want to throw a few $100 at it and try to protect as much as you can. And at that generator, you'd want to put these as close to the electronics in the generator as possible to protect that generator. Because remember, that 50 feet of wire, it's protected on this end over here at the load center, but on this end there is nothing. So that voltage is going to push towards the generator. So if you get this out towards the generator, now you've protected that. Same with your PV array. If you've got a solar array and you've got a battery-based system like we do here, you want to get something at the charge controller. If your PV array is 600 feet away, maybe put another one at the PV array, because again, if you can stop any of that, any place you can stop some of that, the more you can stop, the better chance you have of survival of that. And then, you know, from there, it really just boils down to using some common sense. There's a lot of things that work with lightning and may or may not work with EMPs. There's a ton of reading you can do out there. But with lightning, for example, it doesn't like to turn sharp corners. So if I bend that wire like that, lightning comes in, it's probably going to blow it out of that. So if you're doing something that you want, like lightning protection, you want to use a big radius. Or on these surge arrestors, you want to shorten the wires as much as humanly possible. If you're putting them right at the load center, the panels here and the breakers right here, don't leave any service loops. Make them just as short as you can. And if you got to go back around to get your ground, you know, make a fairly good loop. Don't make a real sharp bend like that and go back into your ground. Those are a couple of words of advice. The other thing you can do, there's a ton of data out there on how to kind of EMP proof the wiring coming in. I've seen metal conduit where it turns and comes back up through another pole, and they shove it full of copper mesh in there to help keep that from coming in. They put all the equipment in a metal shipping container, ground the container, you know, and do all of this. So there's a lot you can do, but just, you know, at the end of the day, it really boils down to the level of guarantee you're looking for versus the, you know, likelihood you feel this is going to happen. If you live wherever, pick your poison. Let's say you live in Austin, Texas, and there's a huge military base right there, and you're 99% sure you'll be the first target, then you've got to plan a lot harder than, like, let's say somebody that lives wherever, pick someplace, but they live anywhere. Up here in Great Falls, Montana, and they're like, you know, there's nothing really up here. I feel pretty comfortable. I can't tell you what the likely target is. My gut tells me that if somebody like Russia or whatnot was going to target us for this purpose of crippling us from a technology standpoint, it would be multiple blasts. If I was going to do this, I'd pick, you know, 1, 2, 3 or 4 places and do it simultaneously, and that way I would guarantee I'd cover the whole continental U.S. But that being said, if you feel like I do and you're really concerned about that, you can go ahead and you can put some equipment in a Faraday cage. You can do your research on how to do that. Build yourself a proper Faraday cage, bury it deep in the ground, etc., etc. There's a lot you can do. But at the end of the day, all I can help you with is what you can do with these things and what you can try to do to better prepare yourself. And again, coming back to that where I talked about anything worth protecting. You've got a $3,000 or $4,000 battery-based inverter on the wall like we do. You put one of these right at the inverter that's on the AC in, another one that's on the AC out. If you've got lithium batteries, they have a computer in every single battery. Probably not the best idea if you're really worried about SHTF. You may want to get yourself some old lead acid batteries because they're not going to care. But if you do have a lithium battery, get yourself some surge protection on the battery too, because now all of a sudden that battery is susceptible. Whereas before, like a lead acid battery, we were very confident that those were actually going to help arrest the surge, not cause a problem. Put these on every charge controller, put these on every load center in the building. Don't forget your neutral. That's another key thing I'll keep driving home. But also when you're designing the system, try not to have it spread out. Like our property in Maine, for example, we have power lines run to a barn, we have them run to a summer kitchen, we have them running from the road, which is 500 feet away. That's just not a good design for an EMP proof system. If you're really thinking EMP proof, contain it all in the smallest footprint you can. And if you have to have a long wire run, unplug it on both ends and put it away. Only plug it in when you're using it, because that wire still, there you go, is another issue. If you're going to bury a conduit in the ground to power an outbuilding, you know, I know it's expensive, but try using rigid conduit the whole way. Now you've put that inside a metal shield the whole way, and you can ground that shield, and that's going to help you. If you use PVC, lightning, not lightning, an EMP blast goes off, it goes right through that PVC. So these are the little things you can do to really protect yourself. But again, keep the system as small as humanly possible. Keep all your antennas as small as possible. And I don't know, find yourself a place where you think you're pretty safe on this map. I'm not sure where that is. I always felt like Maine and now Florida are kind of a little questionable because, you know, that whole DC area is right smack in the middle. I don't know where the right place is because there's probably a ton of military bases I know nothing about that would be targets for certain people. But my gut tells me if you want to cripple the U.S. with an EMP, you're going to hit your major cities. You're going to hit your major places in California, your major places on the East Coast. You know, because if you wipe out every electronic device in a however big circle around California and another one around the DC, New York area, you've put a pretty big hurt on the U.S. There's not going to be any food, electricity, or anything there. And keep in mind that these transformers, now the ones you see on your pole out here, not a big deal. They're usually right in the yard at the local power company. It's the big ones. When you drive by that substation, it's behind the fence, got all those great big transformers and the lines everywhere. Those ones can be, 1, 2, 3 years out to get those. The utility companies don't keep spares of those. Most utility companies do have a mobile substation that they can haul in if there's a problem. So when you see a substation blow up, they bring in that mobile trailer, they get it back online, they can reroute around that substation with other substations. There's a lot of redundancy built into the grid, but there's also a lot of weaknesses built into it. But if there was a blast that took out the grid in a quarter of the US, that's a lot of transformers. And a 2 to 3 year lead time, you're going to be in the dark for a while before they get that figured out. So that's the thing to think about. I think that the way I look at it, the way I prepare, the way I think about it is that we'll do the best we can do for a kind of a, protection standpoint. Like if they do a blast right over us here in Ocala, Florida, we're in the dark. I know we're in the dark. I'm not worried about that. I have no preconceived notions that my equipment is going to survive that. If they do it over Wichita, Kansas, maybe so. But you can only do what you can do realistically. And it's not practical for every one of us to go buy a cabin out in the middle of the woods and go 100% off grid with no electricity. Some people can do that, but that's not practical for everybody. So you have to do the best you can do and be the most prepared you can. At the end of the day, try to learn how to do as much stuff without power that you can do. Figure out a water source around you. If you live like where we do here in Ocala, figure out where you may be able to get water if there's a real problem. Figure out a way to purify that water without electricity. Have that in place. Kind of define some food sources. Freeze dry some food, can some food, stuff like that. Don't rely on freezers as much because if the power goes out, you got no freezer. You can have this right packed full of meat, but if you lose your power because of an EMP and the freezer's dead, you're going to be eating a lot in a hurry. But if you've canned all that meat, it's going to survive for years. So that's my best advice is kind of, figure out where to put these, put them wherever you can, practical, keep your system as small as you can, but also have a little bit of redundancy in your prep where you kind of learn to take care of yourself a little bit with some, freeze-dried or canned food. Plan a little bit on how to find a water source because those are the two things you're going to really need. Protection and everything else is great, and you do want that, but you really want to have a source of water that you can get your hands on, a way to purify it, and some kind of food source to sustain. Because I can tell you, in my opinion, if something bad happens with a nuclear EMP, it's going to be a while before you see somebody from the government, and likely they're not really here to help. So, keep that in mind. I don't know. I rambled a lot there. Hopefully that was helpful for you. Hopefully you got some core ideas. Go research EMPs, nuclear EMPs. Look at some of the information out there. There's a ton of people that have posted a lot of stuff on how to prepare for that. The best thing I can tell you is if it sounds too good to be true, it probably is. You're probably not going to buy $100 for Mylar bags from some company and protect absolutely everything you own against an EMP. So keep that in mind. It's not necessarily cheap, and if it sounds too good to be true, it probably is. So why don't you come back for part 3, and on part 3 we're going to put some power to these things and show you what voltage they actually clamp at, and we'll get as far as trying to blow some stuff up. show you how an electronic device responds with these things hooked up and without these things hooked up. So I'm going to wrap this up. I'm going to quit rambling and look forward to seeing you guys on part 3.